have discussed our 3 topics like I have promised you. We have a rocket build-up lesson, so just stay tuned and we're going to go ahead and get to it. Hi everybody, well today we're going to be talking about the materials that are going to be needed to build this rocket. But first of all, let's go ahead and introduce some of our volunteers that are going to be helping us with our instruments today. Would you mind introducing yourself, please?
Hi, my name is Kevin Andrew Verdusco. I am 12 years old and I'm in 6th grade. This is my cousin.
My name is Hazel and I'm 6 years old and I'm in 1st grade.
Awesome. Thank you for introducing yourself. So right now we're going to go ahead and talk about the materials that are going to be needed for this experiment. So Hazel, can you show us the pair of scissors we're going to be using today? Okay, so we're going to be using this pair of scissors. And also you want to go ahead and use some markers. But right now we're going to have highlighters here that Hazel's holding up. And we usually want to have colored paper, but we're going to go ahead and use the white sheet of white paper that Kevin's holding up. And then we're going to also use tape. This tape is fine. Clear tape is the best because it's going to show you what your rocket looks like. But masking tape or duct tape can also work. And also we're going to be using straws. Plastic straws will do great. If you have wooden straws or paper straws, those shouldn't be, I don't think it should be a problem but if you use them, but plastic ones are recommended. So now we're going to go ahead and talk about the procedure for this experiment. Okay, so now that we have introduced the materials, now we're going to go ahead and talk about the procedure to build this rocket. Okay, as we talked before, we have here 2 volunteers, Hazel and Kevin, and they're going to be helping us out build the rockets. So in order to do the materials, everybody should get a pair of scissors. So go ahead and grab a pair of scissors. Okay, nice. Now you want to go ahead and grab a piece of paper each, please. And then now you want to go ahead and grab a straw. Each have a straw. And then here we have previously cut it out a tape because you know how it could get messy. The tape can fold up and it could be really messy. So if you want to do it beforehand or have somebody cut you tape to help you out build this rocket, go ahead and tell someone to do so, please, because it's going to be very beneficial as when you're taping parts for your rocket. And remember, this part right here that we're going to be starting with is going to be the structural system that will hold the rocket intact, how we talked about in the previous topics. So let's go ahead and get started. How are we guys ready to build rockets?
Good.
Nice. Okay, let's do this. Alright, so the first thing is you want to go ahead and grab your piece of paper. But before you grab your piece of paper, you want to go ahead and fold it 2 times in the hamburger side. Okay, Kevin, can you show us which one is the hamburger way, which one is the hot dog way? For some of us, this is the hamburger way, and then this is the hot dog way. So the long way is the hot dog, and the more thick, more kind of like chubby side is going to be the hamburger. So you want to fold 2 times the hamburger size, okay? So let's go ahead and grab the piece of paper and begin to fold it the hamburger way. And you want to match the corners, please. Okay? So have fun with it. You're at home. It's going to be exciting. It's going to be a rocket. Hopefully you have built a rocket before. If you haven't built a rocket, it's going to be really fun as well. I'm always having fun building rockets, and I think it's also a good experience to do some arts and craft with materials that are recyclable, that you can go ahead and reuse. So go ahead and feel free to do this. You know, have your family members build rockets as well. Your nieces and nephews, your cousins, your brothers and sisters, your mom and dad, your grandpa and your grandma to be able to help you out. So once you're done, like Kevin and Hazel, they have successfully folded the paper in 2 halves of hamburger style, and then now they have 4 equally rectangles, and it kind of looks like a window. So now what you want to go ahead here and do, you want to go ahead and cut out only 1 square, one of the rectangles from that piece of paper. So make sure you cut it very nicely, because this part, like I said, is going to be the structural system that's going to hold your rocket in place, and you only want 1 piece of the rectangle from the big paper, okay? You guys are doing such a good job. So 1 piece, okay? Awesome. So this is really good to cut like this because this is how you can save paper and somebody else can use it. So nice. Can you show me how you cut the one rectangle out, please? Nice. We did a good job. All right, the next thing you want to do is go ahead and grab your straw and one piece of the rectangle and go ahead and start wrapping that paper around the straw. And you want the straw and the paper to be tight enough but not too tight, okay? So go ahead and wrap it around. This might take a while, a couple seconds, a minute maybe, to get it right. And it's okay if you don't do it correctly the first time. There might be other times where you gotta try and just keep going at it and don't give up. Just do your best you can. And like how Kevin is doing right here, once you wrap the paper around the straw, sometimes the edges might not line up, so you wanna kind of like squeeze the sides of it so you can kind of like center out. Look at Hazel, good job Hazel. And then you want to tape the ends, okay, so your rocket doesn't unfold. This is like the cylindrical body shape that we have for a rocket. So go ahead and tape those two edges on the top and the bottom so we can have it really consistent. And then once you have taped it, go ahead and show it to me so we can see how well your cylindrical body is looking like. And then Hazel, before you tape that, tell me why are you taping that? Why are you using that tape for?
So it can stay tight.
So it can stay tight. So if you can see, Hazel has taped the two sides, but then in the center there's a little bit of a unfolding piece of paper. So she's gonna use that tape to go ahead and seal that so that cylindrical body can be fully sealed and there's no air coming out, because it's going to be really, really beneficial for everybody. Can I see, Kevin, how you do? Nice, good job. That's really nice. Okay, let's see, Hazel. Okay, good job. We have successfully done the cylindrical body of our shape. Okay, and then the next thing you want to go ahead and do is go ahead and pinch one of the top sides of the cylindrical shaped body. So pinch one of the ends and tape it. Okay, can you show me how are you pinching it, Hazel, please? Can I see? So go ahead and pinch it. Yeah, exactly, Kevin. Can let me see? People out there at their house want to see how you're pinching it. Awesome. So now you want to go ahead and tape that pinch. Okay. You want to use like probably 2 pieces of tape, maybe 3, but you make sure you that has to be really, really tight. It has to be, that's the most important part of this rocket. That has to be very, very tight. So go ahead and use 3 pieces of tape, okay? Go ahead and use 3 pieces of tape to make sure that it's really tight. Because if you only put 1 piece of tape, it's not going to be a very successful rocket when you try to launch it later on. And we're going to talk about how you launch it later on. So we're just waiting on our volunteers here. They're going to help us out with our rockets. And they're doing such a phenomenal job. Let's see, Hazel, how you're doing. Is it really tight? Mm-hmm. Okay, let me double check for you. Please, let me see. Okay, looks nice. Looks nice. There you go. Kevin, let me just double check yours. Make sure that it's really good. Okay, so you want to go ahead and make sure that all the ends are sealed, that there's nothing going in, no air coming out, because it's going to be very helpful for our rockets. All right, the next thing is you want to do is grab the other rectangle piece of paper that you have and go ahead and start cutting triangles, because the triangles are going to be the fins for your rocket. So go ahead and cut triangles. Okay, you can cut like 3, 4, however many fins you want your rocket to have. Because as we talk in the structural system, we have the nose cone, we have the cylindrical shaped body, and we have the fins. So here it depends on how many fins you want, because you are the engineers, you are the scientists that are building the rockets. So this model is going to be your model, like how previously different kind of like shuttles we have seen, like the space shuttle or like the Apollo mission programs, rockets. You have different kinds of different fins, different styles. So now you want to go ahead and tape those fins into the cylindrical body, please. And if you need tape, here's some more tape. I believe there's some more tape right here. Go ahead and grab some tape and tape them. And we're almost coming to the end of the rocket buildup. So as you see here, we have different kind of styles of rocket that you can go ahead and do at home. You can have a little piece of clay on top there. That's going to help for the body distribution, for the weight. You can have one like the one preview here. You can paint your fins, or you cannot. This is here like kind of like whites, because it depends on what kind of paper you're using. Color paper, or maybe you want to do your design by painting any of the with the markers or crayons, so you can make your design. So now after this, we're pretty much done. Hazel, is that you're all done with your rocket? You don't want to tape it no more? You have pretty loose fins, but that's fine if you want to keep it like that. But you want to make sure it's pretty much close to the body. You see how Hazel was doing it? Her fins are not close to the body. They have to be really close to the body to be very, so when your rocket launch, it doesn't go off trajectory, or it doesn't go off its path. So go ahead and put it more closer, Hazel, kind of like the ones right here. You see how they're pretty close to the body? And put them more closer so it could be. Okay, you guys are doing such a great job. So now that we're done with this, we're gonna go ahead and put our straw back into the piece of paper. But make sure you don't put your straw all the way in. Just go kind of like halfway, not all the way in. Make sure it's pretty loose. All right, so now we're ready to launch. How are you guys doing? You guys feel ready that you guys launch?
Yep.
Okay, but hold up. Before you guys launch it, let me let you know something, a little secret, okay? As engineers and scientists, not everything goes right the first time we do it. So if your rocket does not fly, then we have to think about what variables, what problems might have happened in our buildup, because sometimes some things might happen. There might be a hole, or we didn't do something right. So don't be discouraged if something doesn't go as planned, okay? So just go ahead and try it. So we're gonna go ahead and launch with Kevin first. So Kevin, go ahead and launch it to the wall. Let's see, hold on, let's give it a countdown. Hey, so let's count from 3 to 1, okay? Let's count and see how it goes. 3, 2, 1. Okay, nice, successful launch. All right, now let's do Hazel. Hazel, you ready? Let's count. Kevin, please. 3, 2, 1. Nice. So they both successfully launched. Which now can we go ahead and see your rockets, please? Because at home, people might want to have an idea of how their rockets might look like. And remember that you can go ahead and color it, and you can shoot it up the air. So now go ahead and put your straws back in there. And now you want to shoot it up to the sky vertically. And let's see how far they go up, okay? You ready? Wait, I'm going to count down, okay? 3, 2, 1, 0. Nice. All right, now you, Hazel. 3, 2, 1. Good job. So there you have it. You have successfully built a rocket. I want to give thank you to Hazel and Kevin for doing a phenomenal job at explaining this. You guys want to say some words of how much fun you guys had building the rocket, please?
We had so much fun, and now we know how. It's really good to advance your crafting skills, because if you want to do crafting or be an engineer when you're older, this is kind of like an idea.
Good job. What about you, Hazel?
It's really fun to make stuff with paper, scissors, and colors, to tape and straws.
Okay, thank you. Thank you for your help.
Can we see it?
So now I want to go ahead and ask you, how was it building a rocket? Was it challenging? Was it fun? Was it easy? I want to go ahead and want to see your rockets. So go ahead and send us feedback or pictures of your rockets, and you having fun building, if you use colored paper or what kind of other techniques do you use to build your rocket. And I really want to see that because it gets me excited. But also, I want to go ahead and explain and relate how the rocket that we just built, how it goes hand in hand to the material that we just discussed. Okay, so here's the visual about the rocket that we built. It might look like this, it might not look like this, but this is the one that I prefer to talk about because it's the one that I kind of like address. So if you look here, you have different color coded letters that signify different things. So if we look at the black part, everything of the rocket here is in black. This is going to be signifying about the structural system. At the very top by the nose cone, it's color coded in violet or purple. This is where the payload system is located, but our rocket doesn't have one. It doesn't have one because it doesn't have anything to transport. But if we were to make a nice rocket, we should be able to put a payload system in there. Also, in red, you have the propulsion system. Here, your propulsion system is your straw because you're acting as the engine by blowing and generating that thrust that we needed in order to lift off the rocket in order to fly. So you are going to be the propulsion system, but that's where the propulsion system will be. And then in green, it's kind of like underneath the payload system is the guidance system. Here we don't have any computers or radars, so we're just depending on the amount of force that we blew of air, and then also the fins that we use, because different sizes of fins can definitely drag the rocket down faster or make it float in the air, whatever it could be, but depends on the rocket. But here I just want to make sure that I compare what we just described for the rocket that you just built.